What's poppin', dogs? Mr. Allen here with some application of non-right triangle trig. We got a navigation problem here with the one and only T-Pain, who is sailing on a yacht, traveling at 9 knots per hour for 3 hours at a bearing of 35 degrees. So that's off of north, 35 degrees off of north. He then picks up Snoop D-O-double-G, Snoop Dogg, and then heads south 40 degrees east. So you're 40 degrees off of that south line there for 2 hours at a speed of 7 knots per hour. How far is he from port? And what bearing should he travel to get back? All right, I think the setup for these things is the toughest part. And the math comes in a close second there for these types of problems because there's a whole lot going on. But if you don't have a good setup, then it makes it even tougher. Now, some teachers will set it up for you, which makes it a little bit easier. But we're going to set it up ourselves. I'm going to show you guys how to do that, okay? Or at least how I think about this. So if he's starting by going 35-degree bearing, right? That's 35 degrees off of north. 9 knots for 3 hours, that's 27 nautical miles. So he's going north for 27 nautical miles. And then we're going south 40 degrees east, but for only, 2 hours at 7 knots for only 14 hours. So I'm thinking I'm going to have like a triangle situation going on here where we start down here, work our way up, come down, but not quite as far south as port already was. So we're going to have like a triangle kind of going on like this. So I'm going to set up a few little compasses, as I like to call them, to help us, get started here. So I'm going to start down here. This will be our port. All right. So we go, whoop, there's one. And here, and I like to be as neat as possible, so I like to use a straight edge for these things. Okay, so this will be port. We'll label that port. Okay, and then he travels up far north. I'll come up a little ways here, so we have enough room to work and do some things here. So we got our next north-south guy. Some people just do a vertical line. I like to do a whole little, compass action here. And then the last one I'm thinking is going to be somewhere right around over here. Not too far. Don't want to get in the way of my calculator there. Okay. So this is where he gets Snoop from, right? This is Snoop. Snoop-a-loop. All right. Beautiful. So we have our general idea, and then he comes back home this way. Let's see if it all works out. Hopefully it does. Otherwise, this whole thing's for naught. No pun intended. All for naught. Get it? Different type of knot. Nautical jokes. You'll get it when you're sailing one day. Okay. So first thing here, let's get a better longer straight edge. We're going to sail from port to pick up Snoop-a-loop. So we're going to draw a line from here to this guy here. And then we'll label some angles, okay? So we got that one, and that's at 35 degrees. So this right here is 35 degrees. That one, just that angle, which can also be used because we have a north line here, which is parallel. Those two north lines are parallel, right? These two angles, the 35 and this one here, those are alternate interior angles, if you recall, from the wonderful days of geometry. Yes? Love me some geometry. So this angle here is also 35 degrees. Okay? Beautiful. Wonderful. And our distance, we said, was 27 nautical miles. It's not km because that'd be kilometers. Knots? We'll just go with knots. I'm not a sailor, okay? So if there's any sailors on here, feel free to comment what I should actually say there. Nautical miles, knots, I don't know. I think that might be okay. Anyways, now the next thing we're going to do here is we are going to head over south 40 degrees east to that next spot. So we'll draw a lovely little line right there, connecting those two. And then we can label some things here. So this is... this would be the 40 degrees off of that south line, so that's the 40 degrees east, which now we have a working angle right here of, 75 degrees by adding those two together. That's nice. Where else could I use that 40 degrees? Well, this angle here, these two north lines, alternate interior angles would be these two. So this is also 40 degrees. I don't know if I'm going to use that, but I'm going to label it right now because it could be helpful in the future. And then the last thing I'm going to do is I'm going to connect these two here to make our final little Bermuda Triangle, if you will. Not really. Hopefully they don't get lost. Okay. Lovely. I think I'm going to label the distance as well. 2 hours at a speed of 7 knots. So we're going 14 nautical miles. Or 14 knot. I feel like it should be nautical miles, but whatever. We're going to roll with this for now. I don't have enough room to write nautical miles. Okay, cool. So we want to know how far is he from home, right? So this is something that we want right there. And we also want to know at what bearing he should be traveling. So our bearing that we're looking for is this. That's what I want. These two pieces of information, and I've solved the problem that I'm being asked to solve, right? So those are the two things that I need here in this situation. Let's see if we can get them, right? Well, right now, right off the bat, I have a side, an angle, and a side. I can get the distance that we are away using law of cosines. I'm not going to write that all in because I want to have room to work for some other stuff. So I'm just going to type it all in the calculator right now and get my x value. So if you remember, and I don't usually, but I'm going to hit second square root right now so I can type law of cosines in and square root it to get x, right? So we got 27 squared plus 14 squared minus 2 times 27 times 14 times the cosine of that 75 degrees. Close my parentheses. I think everything looks pretty dang darn good. We got 27.006. So I will go ahead and say, yeah, 27.006 and change. As a final answer, we'll say 27 nautical, or knots, whatever we're saying right now, from port. So I've already got one of them done. Whee, star. I don't know why I need a star there, but that's one of my answers, right? Cool. Now I need to know at what direction should we travel to get back to port. Kind of important, right? If we're navigating here, yes. So how can I do that? Well, we want just this piece right here, right? Cool. So I could either find that directly, or I could figure out what this part is to here and subtract that from 360. That would also give me this orange piece right here, right? So if I were able to get all of this, I could subtract that green from 360 to leave me with the orange. Now I've already got the 40 degrees. Is there a way that I could get this angle right here? Yes. I have an angle with a side across from it. I want an angle and I know a side across from it. I can use law of sines to set up and solve this wonderful angle, okay? So let's set up law of sines. I'm glad I have a little bit of room right here to work. It's going to be helpful. So we're going to have sine of 75 over this side that I just calculated, 27.006 and change. I will use that in my calculator, right? I'm not going to use 27. I'm going to use the actual right there. It's very, very close, but I'll just, yo-ro. You only round once. And then I want this one right here. I'll call this, I'll just call it theta for all intents and purposes. In all intents and purposes. I don't even know. I think that's the same. Sine of theta over 27 was our given side length. And now we can cross multiply and solve. We got 27 times the sine of 75 equals that 27.00. This is really, really close. This is probably going to be right about 75 degrees. 27.006 times sine of theta. And then we'll divide by that 27.006. And then I can type all that into my calculator in my sine inverse, right? Because all that needs to be in a sine inverse. Sine of all that jazz. Cool? That's how we'll get theta by itself, which you can barely even read right there. All right. So we're going to hit second sine, and then we'll have 27 times sine of 75, close my parentheses, divided by, and I like to type it in like this, because then I can arrow up, hit enter, and it will plug it in where I want it. If I did the alpha x or alpha y equals to get a fraction and type it in like this, then I can't arrow up and grab that non-rounded value or very little rounded value, right? Because it's got a lot of decimals. It would put it in the numerator, which is unfortunate, right? I'd have to do something else. I'll show you that anyways. But here we go. I'd get myself 75.95. If you wanted to type it in as a fraction, you'd have to do, actually, I'm not even going to show you that. Never mind. We're going to go with this. Okay. So 74.951. So very, very close to the 75 degrees as we figured, right? So 74.951. So how are we going to use this? How am I going to get my bearing here, right? Well, I'm going to add that to the 40 degrees right? That's the 40 plus the 74.951 in the green there. And then I'm going to do 360 minus that jazz. And that is my bearing, okay? So this is answer number 1. I'll do it in orange, so those are our 2 final answers. And then we have a bearing of 245.048, so 0.5 degrees. Nice. Now, you may also be asked, I've seen them ask to figure out your compass directions, right? So what are your compass directions here? Well, we're 245 to go all the way around here. So how far past 180 are we? If I subtract 180, I get 65. So you could also write this as south 65.05 degrees west. That would be another way of writing that if they asked you to do it in like cardinal directions or compass directions rather than bearings. So look out, see what they want you to write it as. I've seen them ask for both of them, but that's how you would do that from a bearing to get your compass direction instead. So there we go. Cool, man. Well, that's wonderful. We drew it up right. Crazy that it was actually that close because I just made these numbers up on the spot. Did not plan that, but it's kind of cool. Hardest part, drawing it up. Try to get a visual as to how far you're traveling. How steep that travel is how I also look at it. 35 degrees off of north versus 40 degrees. Those are pretty, comparable in the steepness world. But this one being such a short distance as compared to this, I knew this guy right here was going to be above this one and not below. Because if you do it below, then things start to look weird. You can't visualize this part properly. So the drawing really matters. Make sure you really think about it before you plot it all out if they don't give it to you. All right. Other than that, you guys have a wonderful day. Stay dope, awesome, and see you later.